Hey guys, let's dive into a review of one-step equations. I say a review because you did these actually last year in the sixth grade. So I'm just going to kind of refresh your memories on what they are and how we solve them. And you might start to hate me, but I am going to require that you write down every single step, even if you can do it in your head. Even if you're looking at this equation right now and you're like, oh, I know what x is. Great, that's awesome. I'm so glad. I still need to see every single step. And this is the reason why. Pretty soon, we're going to be solving equations that don't look like what's on your screen now. They look like, let me pull this over, this. All right, check this out, guys. We have variables in multiple different places. We have an x here in parentheses. We have an x here not in parentheses. We have an x on the other side. We're going to need to combine like terms and use the distributive property. And my point is, if you don't know the steps that are necessary to solve a simple equation, then there is no hope for you in solving the more complicated ones. So, grin and bear it. Roll your eyes at me if you want to, but I'm only giving you full credit if you show all your work. Okay, so this is the first thing that we need to do is we need to think about, okay, well, what do I really want to accomplish here? Eventually, what we want is we want to wind up with an answer that has our variable by itself, an equal sign in the middle, and some number over here on the other side. And our goal really is to figure out, well, what is that number? What does this x have to equal in order for this equation to make sense? So that's where we're headed. So the first thing that we want to do before we even get started is draw the river. And you know me, I like to name things in math because I think it helps us remember, just like knocks the box, you know. So I don't just say that we are drawing a line, I draw a river. I draw this river straight through the equal sign to separate my equation. So I have a left side and I have a right side. And the reason why I do this is because it helps me organize my work. Because if I do something on the left side, I have to come over here and do the exact same thing on the right side. Otherwise, we're going to mess up the balance here. It'll be a seesaw that isn't, well, a balanced seesaw, okay? So that's the first step that you always want to do is draw your river. Okay, now we get to this point here where we see that we've got kind of a mess going on here. This is what I call a double sign. I have a plus and I have a negative right smack dab next to each other. No number in between, no parentheses. They're just right next to each other. And so we want to clean that up a little bit before we start to really do anything else. We want to say, okay, listen, this is a mess. Instead of x plus negative 3, I'm going to say, well, that's just the same thing as x minus 3. It's sort of kind of like leave change opposite going backwards, right? We learned when we were subtracting integers that we would leave change opposite in order to do the math. Well, now we're going backwards to kind of clean it up a little bit. So everything else is going to stay the same. So the equals is still right there on the river, and the negative 12 is over here. And I'm going to erase all this. Hold on. Okay, that's better. All right, so now we have an equation that we can start to solve. So remember what I just said. We wanted to get this variable by itself. And so we just look at this side of the river. I don't really even care what's going on over here. I'll erase that squiggle in a minute. But I'm really just focused on this side because this is the side with my variable. And so I asked myself, all right, if I want x to be alone, if I want to get x by itself, what do I need to get rid of, basically? And the answer is this minus 3. So then the question is, well, how can I do that? And the answer is we're going to make a zero pair. Because if we have, think about it, if we have x and a 0 next to it, well, that's basically nothing, right? That's just like having x by itself. So we want a zero pair. We want something to put with this minus 3 or this negative 3 to make 0. What would that be? Well, I'm going to give you about 5 seconds to think about it. What would pair up with this minus 3 to make a 0? And hopefully you said a plus 3. So we are going to add 3. That is going to give us a 0 pair. Or in other words, you could think of those as canceling out. All right, now I need to erase this squiggle mark so we can actually see what's there. Okay, so this is where my river comes in handy because I know that whatever I do on one side, I have to do the exact same thing on the other. So clearly I added 3, so I'm going to add 3. Okay? And so when we add, we typically, stack them vertically and draw the line. These have canceled out, so I don't have anything left here except my x, which is good because that's what I wanted. I wanted to get the x by itself. The equal sign is still right here in the river. And now I do the math. So I have a negative 12 plus a positive 3. Well, negative 12 and positive 3, the signs are different, so I'm going to subtract them. I will get a 9, and it's going to keep the sign of the bigger number, which in this case is 12, so my solution is negative 9. At least that's what I think it is. I'm not sure until I check it. So, in order to check, we write the original problem. So we have x plus negative 3 equals negative 12. And what we're doing here, guys, is we're just going to say, okay, let me plop this baby in for x and make sure that it works. Okay, so we're going to talk about something that I call the parenthetical promise. We have an oath that we're going to sign in our INBs in a little bit. I think it's in Unit 3. But basically, anytime you're plugging in a value for a variable, you have to put parentheses around it. It's just my rule. It's the parenthetical promise. So instead of x, I'm going to write parentheses, and I'm going to put my negative 9 in here. Okay? There is a reason why that we will get into in Unit 3, but just know you need parentheses around them. Okay, so now we bring everything else down. So the plus comes down, the negative comes down, the 3 comes down, the equals comes down, the negative 12 comes down, and my final step is to do the math. Now, I'm going to pause for just a second. There is a code word of this video. You need to write this code word down, and I'm going to be looking for it when I check your homework, and that is how I'm going to know that you actually truly watched this video and listened to it. And the code word is wonder, because Wonder is my dog's name, and she's sitting right here at my feet. Okay, so write that down with your work on this equation so that I see that you actually watched this video and listened to it. Okay, so now we do the math and we say, well, a negative 9 plus a negative 3, yay, that is negative 12. I have a negative 12 on the other side, so I know that I'm right. Again, you guys, I know it looks like a ton of work, especially if you might have just right off the bat seen it was a negative 9. You still have to show all your steps. Okay? All right. See you tomorrow or whenever. Bye.